Hello, my name is Lara and we're the team PSEINT, integrated by Mariana Sosa, Flores, Gracia, and Verdugo. And today we're going to present you our interactive learning project. But first of all, we're going to define some concepts that we're mentioning during this video, like the mean square error, machine learning, linear regression, and optimization. But what is mean square error? Well, this is the most used function of error. It measures the average square differences between the values that we already have and the predict ones. Using this formula, these letters make reference to the mean square error. This n is the number of data that we have. This letter is the actual values and this letter is the predict ones. Well, this metric is also commonly used in the machine learning, that it's a type of artificial intelligence that can make tasks without specific instructions.
Linear regression, a method to predict one variable using another by finding the best straight line with the least squares method. Optimization is the process of finding the best possible value of a function, either a maximum or a minimum, within a set of constraints.
For our project, we're going to use a linear regression. Well, as its name says, it has a linear pattern. And we're going to use it in order to predict new data with more precision. And well, our project will be based on a relation between the engine size and the CO2 released by this. Well, in order to solve our problem, we're going to use two variables, y and y hat. Y hat represents the function that with the data that the computer will predict, and y represents the data that we have actually. And well, y is represented with the blue points. There are like a lot of them. And y hat is represented with the straight line that we are going to create.
Okay, so now, after we get our data from our graph, we want to use the mean squared error. The purpose of the mean squared error is to minimize the amount of errors our computer's predictions could do. So this is the equation for MSE. This is the function, and this is our y minus y hat to the square. It's squared because we use the mean squared error, but the real purpose of the square is to make sure that we don't have any negative values. Y represents the true values that we know that we got from our data set, and y hat represents the values that our computer is predicting based on these. And what we want to do first is y hat. We want to replace y hat with the formula that we have for y hat, which is mx plus b. Then we want to apply chain rule. So we multiply the 2 over here, and we're also going to start derivating partially. First, we start derivating for m. So the 2 goes here, minus 1, so it's only 1. And then we derive what's in the center. Y and b are constants, so they're 0. M is derivated into 1. So we basically have here minus 0 minus 1x. 0 minus x. So basically, and this is just minus x. So what we're going to do now is the negative side of the x, we're going to multiply that with the 2. We'll multiply that by the 1 over n. So our derivative with respect to m is minus 2n, y minus mx plus b, multiplying x. Now, if we were to derivate for b, first we will do chain rule. And then we will start for the derivative of what's inside the parentheses. Y is 0, mx is 0 too, and b is 1. So it will be 0 minus 1, which is right here. Then we just multiply minus 1 times 2 times 1 over n. And we have minus 2 over n with our function.
As we know, this is a positive coordinate equation, then we know that it's going to be concave upward, and there is going to be a minimum value. How do we find this value? We have to equal both derivatives to 0, since it's going to be 0 slope. It's going to be like this. It's going to be a straight line. And by solving it, we're going to get the m, b values that make the mean square error minimal.
As we said earlier, by doing this, by minimizing these values, we could find the best coefficient that best fit our data. For example, we must find a linear equation that best fits this data. Why a linear equation? Because we're not going to find a function that goes through every single dot. It's not possible, and that's why linear regression is why it's such a good option. So after finding these values, as we can see, we get the coefficients. This is the slope and this is the intercept. By making a linear function with this data, we get something like this. And as we can see, every single dot is not that far from the linear equation, and that's what we're looking for. That's what we're looking for, finding the minimal square error. And with this data, we minimize the mean square error. So that's basically it. And as we can see, we get the R2 score, which means approximately 0.76%, which is like 76% of accuracy, which is good for a linear regression model for predicting CO2 based on the engine size of a car.